Okay, so page 4. If we get through this page, we can begin quiz review, and we'll be able to have full day Monday to do quiz review as well, and then Tuesday the quiz will just be over these two sections, working with double angle identity and working with Pythagorean identities, or sorry, sum and difference identities. Okay, so number 1, it says use the figure to find the exact value of the trig function. Okay, we have the triangle filled out mostly for us, but it'd be helpful if we can find the hypotenuse. Pythagorean theorem, a squared plus b squared equals c squared. What's our hypotenuse going to be? 5. Okay. So once you have all 3 sides of the triangle found, then sine of theta, cosine theta, tangent of theta, they're all right there for us to just pull. So tangent of 2 theta, we're going to expand that out. We look at our identity sheet here, tangent of theta, sorry, tangent of 2 theta. This is a double angle. Understand that anything that is, the reason why we call it double angle is because that angle measure is not just tangent of theta, it's tangent of 2 theta. So it's not tangent times 2 theta, right? So you have to understand that 2 theta is something that's a little more difficult to work with. So we have this formula to kind of expand it out in terms of theta. So tangent of 2 theta, we can expand. Now, whenever you see tangent squared theta, this is a shorthand way of saying that they want the entire tangent of theta squared. So sometimes writing it out this way requires more things to write out, but it is more visually, it's more beneficial because you know, okay, it's the entire tangent of theta is being squared. If you look at this notation, tangent squared theta, it may not be, it may not make perfect sense to you, but just understand that these are the same things. Okay? The reason why they write it this way is so that they don't have to write as many parentheses, but it's squaring the entire trig function. Okay, so tangent of theta, what's tangent of theta equal to? Based off this triangle. SOHCAHTOA? Yeah, opposite over adjacent, right? 3/4. Okay, so that's all we need to fill in. So replace tangent of theta with 3/4, and then we'll just resolve that fraction, get it down to a number. Okay, for now, we can use our calculators. This gives us 3/2. (3/2) divided by 7/16 reduces to be 24/7. So that's basically what we're doing for the entire page here, just filling out the triangle, identifying all the sides, and then we can replace every tangent theta, sine theta, cosine theta with ratios that we find from the triangle. Okay, next up, cosecant of 2 theta. We may not have a trig identity for cosecant of 2 theta, but we have something that's related to it. What's that? Yeah. So how can I rewrite cosecant of 2 theta? 1 over sine of 2 theta, okay? Sorry, sine of 2 theta. Sine of 2 theta can be expanded out to be 2 sine theta cosine theta. And now we just have to replace with appropriate trig ratios. All right, what's sine of theta? 3/5. Okay, what's cosine of theta? Adjacent over hypotenuse, 4/5. This gives me 1/24/25. Dividing by a fraction is the same thing as multiplying by the reciprocal. If I flip that 25 or this fraction up, this will give me 25/24. All right, any questions here? Yeah.
How do you get cosecant 2 equals sine theta?
Well, because of this relationship here, we know that cosecant, is equal to 1/sine. So because of that, we can also make that same conclusion for cosecant 2 theta. Yeah. All right, everybody good? Number 1 and 2. All right, moving on to 3. So the additional challenge that we have with 3, I think we saw this yesterday, where they give you a trig ratio, and then you have to build the triangle out. And once the triangle is built out, then you can pull everything that you need, whether it's sine theta, cosine theta, tangent theta, as soon as you expanded your double angle. So let's first figure out where to draw this triangle. Tangent of u equals -5/12. U is between pi/2 and pi. All right, where is angle u located? Second quadrant, okay? Between 90 degrees and 180 degrees, that's second quadrant. So let's draw our triangle in the second quadrant. All right, careful with the negative, okay? Because even, they could have had this being -5/12, but we gotta be careful because, depending on where we are, we have to make sure that we assign the negative to the correct side. Okay, so SOHCAHTOA was tangent. Tangent is opposite over adjacent. Can I say it's -5/12? 5/-12. I think I made that mistake yesterday as I was working through one of the problems with you, because I saw the negative with the numerator and I put a negative here, but this is a positive y value, right? So it's going to be 5/-12. Everybody okay with that? Okay, and then now we can find the hypotenuse, Pythagorean theorem. (25 + 144 = c²). We take the square root. C = 13. Your hypotenuse is always positive. Okay. All the information that you need is in front of you, because now I can build out sine of 2x, cosine of 2x, tangent of 2x. Just expand each of the angles here. Okay. I'll start with sine. let's find the appropriate replacement for each of these trig functions. What's sine of u equal to? 5/13. Cosine of u? Negative 12/13. Make the calculator do the work for you. You basically have the answer, just have to get it down to a cleaner number. Cosine of 2u. Any of these options is fine. You can either do cosine squared minus sine squared, or 2 cosine squared minus 1, or 1 minus 2 sine squared. I'm going to just choose 2 cosine squared minus 1. But any of those will work, okay? Understand that when you see that cosine squared, okay, understand that cosine squared u means the entire cosine trig function is being squared. Okay, we already found cosine, right? Cosine is negative 12/13. Any questions with that? Okay, next up, tangent of 2u. Two tangent u over 1 minus tangent squared u. All right, what's tangent of u equal to? Oh, we already have it. Okay, so negative 5/12. Okay, insert this into your calculator, get down to a manageable fraction. All right, what can we conclude here? Sine is negative, cosine is positive, tangent is negative. Which quadrant must we be in? Fourth, yeah, fourth quadrant is the only quadrant where cosine is positive and everything else is negative. Okay, what do you guys think? Manageable? I think the hardest part is just trying to get that triangle, right? Get that triangle created, make sure it's in the first quadrant or in the correct quadrant. Make sure you're assigning the sides correctly, whether it's negative or positive, and then Pythagorean theorem correctly to get to that third missing side. If you can get that triangle figured out, the rest of it is just doing a whole bunch of substitutions. Right? So hopefully that doesn't feel difficult for you. Okay, so can you guys try number 4? I just want to see your progress before I show my steps with you. If you did not bring your calculator, it's okay. You can still get to the point where right before you enter the calculator by hand, so that yeah, and as a reminder, every triangle that you draw, no matter which quadrant it's in, make sure that x-axis is always a side that is part of the triangle. Yeah.
Yeah.
Triangle's the hardest part. You get that triangle down onto the That's right. Yeah, what's this about? A squared plus b squared equals c squared. 16 minus 4. Little squares, isn't it? 16 minus 1 is 15. It's squared is down. But you're going down. So negative. Down. Left. Down. Even though it's switched out. Yeah. Yeah, that's right. You're right. Okay, positive.
No, it's always that square. So it's just two sides.
Yeah, so did you put 2 times negative root of 4?
Yeah.
Times negative 1.
Yeah. 215 over 16.
Yes.
Okay, a couple things I want to walk through. Make sure that your triangle looks good. Cosine of u. We're dealing with the third quadrant because u is between pi and 3 pi over 2. Make sure that you're always drawing your triangles correctly, that you're extending out from the origin, okay? And then you're always involving the x-axis in your triangle. Don't involve the y-axis. Don't draw your triangle any other way. Okay? If your triangle is not drawn correctly, everything's going to be thrown off. Next, make sure that you're doing SOHCAHTOA appropriately. -1 over 4. The negative goes with the 1 because hypotenuse is always positive. So -1 over 4. The third missing side, you can use Pythagorean Theorem. A squared plus b squared equals c squared. When I solve for b, I got root 15, but I need to assign negative for this side because I'm going down, right? Anytime I'm in the third quadrant, I'm going left, I'm going down. Anything in the third quadrant, x and y values are both negative. Okay, that's the hard part. If you can get that part, everything else, you're just doing SOHCAHTOA, replacing all those sine, cosines with trig ratios. I should be able to reduce this a little bit more, right? So do you guys get root 15 over 6? Sorry, root 15 over 8. Okay. Yeah, so right now my biggest concern is can you get that triangle drawn? Because everything else is going to be easy after that. Yes?
I think it was quadrant 2.
Okay, good. So we're talking about 2u. We're not talking about the original u, so it's not going to be the same. So the way we can tell whether it's quadrant 2 or which quadrant it's in, we look at the sine, cosine, and tangent that's already been provided. So here, sine is positive, cosine is negative, and tangent is also negative. The only quadrant where the sine is positive and everything else negative is going to be quadrant 2. Okay, let me come around just to see how you are able to draw your third triangle for number 5. gives me peace of mind that we were on the right track to get that triangle drawn. Okay, any questions with number 5? Yes.
Yeah, the first one.
I don't find the
Okay.
adjacent.
Okay, let's see. Okay, so let me start from scratch here for number 5. You guys good with fourth quadrant?
Yeah.
Okay. So even though if you're just looking at cosine is greater than u, then you're not quite sure, right? It's okay. Could be first, could be fourth quadrant. But the fact that sine is negative and cosine is positive, that kind of narrows down the option, right? We're dealing with the fourth quadrant. Negative root 5 over 7. We know the negative goes with the root 5 because the 7 is always positive because we're dealing, 7 is the hypotenuse. Are you guys good up to that point?
Yeah.
Okay, so now Pythagorean theorem can help us find this adjacent side here. A squared plus b squared equals c squared. Negative root 5 just becomes 5. (49 minus 5), 44. Good so far? Take the square root of both sides. A equals root 44, which is same thing as 2 root 11. And now everything is just the same after this, right? Good. Okay. Okay, after we're done with this, I'd like for us to at least try to get through 1 and 2 on the quiz review, just so that we can kind of make sure we don't forget about sign and difference. But we should do 2 more problems on the next page. Okay, any questions at all about number 5 that you want me to go over in detail? I feel like once you can get that triangle drawn, everything, you're just replacing all your trig ratios with fractions. Okay, who else needs this page? Everybody good? All right, let's go to the next page. Let's just do 1 and 2 and we'll be done, okay? So this is the quiz review page. It says find the exact value using angle sum or angle difference identities. If you look at 105 degrees, this is not an angle that stands out to you because it's not one of the special angles. But what we want to do is we want to be able to use sum and difference to our advantage. So we want to think of, is there a way that I can add 2 special angles together and get to 105? So think about angles such as, 30, 45, 60, 90. Can you find 2 numbers two of those special angles that add up to be 105 that will be easy for us to pull from the unit circle. 60 and 45. There we go. So there's our A and B value that we can use to build from our sum and difference. So I'm going to write that formula, and we're going to apply it. Doesn't matter what your A and your B value is. You can make it 45 and 60. You can make it 60 and 45. Okay, it'll work out. I'm just going to go with 45 and 60, but if you did the other way, you'll come up with the same answer. So for me, I'm going to let A be 45, and I'll let B for 60. Okay, use your unit circle and replace each of those trig angle measures with a ratio. Oops, sorry, I messed up here. It should be 45 and 60. My bad. Questions with number 1? Okay, number 2, same idea. 17 pi over 12. That doesn't stand out as an angle that we recognize. But can we think of two fractions that adds up to be 17 over 12 that could be ones that falls in our unit circle radian measure? Say that again, DJ?
5, 4 plus 5 is 6.
We want 17 though.
Yeah, 15 power 12 plus 12.
Oh, okay. Yep, that works. So again, you have multiple options, right? As long as you can find something that works. There may be other options besides this. I did 9 pi over 12 and 8 pi over 12, but yeah, this works. 15 over 12. Okay. So if we reduce this, we recognize pi over 6, and we recognize 5 pi over 4. Right, those are perfect. Okay, go to your unit circle, tangent to pi over 6. Tangent is y over x. So 1 over root 3. Tangent to 5 pi over 4. Y over x. I get 1. All right, are we okay with 1 and 2? I'll make sure that we're still feeling that we're understanding the sum and difference identities. Okay. All right, I was going to check your page 4 and page 5. Okay, go ahead.
Just ask him.